We'll see the examples of grammar construction. The set which we are going to consider for today's this class is given here. First example A talks about construction of a context-free grammar that will generate the language which is equivalent to the given regular expression. Now here when we talk about regular expression, we can very well divide any regular expression into sub-regular expression like by this. Like our given regular expression is this star followed by 0, 0 or 1, 1, which we can divide into two major parts. First part is this and second part is this. Okay, let's refer this part as A and this part as a B. Okay, now this B can also be divided into two sections like this. Let's say B1 followed by B2, right? Either B1 or B2. Similarly here, this whole thing, A is nothing but, let's say, C star, because this is clean closure of this whole bracket. This whole bracket I'm referring here as a C. This C consists of two subsections. One is C1, other is C2. C1 or C2. In this way, we'll try to divide this and likewise we'll construct our variables, consider our variables for the required grammar. So let's start constructing the grammar for this. S gives. Now this is consisting of part A followed by part D, which is nothing but the concatenation of two variables. Let's say A concatenated with B, where A is nothing but what? Either 0, 1 or 1, 0 and its whole star. That means it can repeat 1, 0 A like this or 0, 1 A. It will either take 0, 1 or 1, 0. 0, 1 I am referring as the C1. This is our C1 part. This is our C2 part, right? Or else it is having clean, so that means epsilon is also accepted. Bar epsilon, right? So this is about our first part. This one, this we covered already. Let's focus on part B. B is either B1 or B2, which means either 0, 0 or 1, 1. You can very well write the generalization like this: 0, 0 or 1, 1. So our required grammar G is equals to, how many variables do we use here? Three variables: S, A, and B. So non-terminals or variables are S, A, and B. Terminals are the last symbol which are available in the regular expression. That means either 0 or 1. P is a set of production rules. This whole thing is nothing but our P, consisting of 1, 2, 3, 4, 5, and 6 production rules. Last but not least is S, which is nothing but starting variable. Is this clear with the first grammar construction?
Sir, why didn't we take A and B as a termination? Because terminator, because they are also coming in 1, 0 A, 0, 1 A, epsilon.
So this A will get terminated with delta epsilon. What we are trying to generate out of this is 0, 1 or 1, 0 whole star. This whole thing we are referring as a. Okay. What does this mean? It means either epsilon or 0, 1 or 1, 0 or 0, 1, 1, 0 or 0, 1, 0, 1 and so on, right? Any combination which can derive out of any number of times repetition of 0, 1 or 1, 0 or both. That is what we our target, right? In A.
Okay, sir.
For that purpose, we took once 1, 0 A, in the other case, other production as a 0, 1 A, and This can repeat itself for any number of times, which will get terminated with the level of epsilon. This is epsilon. Or you may not have this 0, 1 and 1, 0. You can have directly epsilon because of clean closure. So that case would be this epsilon, right? So epsilon is acting as a seed for termination of the production rule, which is starting with A here. And B is nothing but this remaining portion, 0, 0 or 1, 1. So we have directly taken either it will generate 0, 0
or 1.
or it will generate 0.
Okay.
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 So this is grammar number 1, which is given here. Let's go for the second case now. What does it says? Can you please read me? Read for me.
There's a
Question number
W
1B.
equals to WR means any string starting which has terminal 0 or 1, which gives the reverse order of the other string.
WR is we are referring as a reverse of W, right?
Yes,
We
sir.
need to go for such a string which reads same forward and backward.
Yes, sir. Forward and backward.
What does it mean? Mean palindrome.
Palindrome. Yes, sir.
Correct. Moreover, what
We
does it
have all.
says? That W mod W is even. That means we're not talking about general palindrome. We're talking about a palindrome whose length is even.
Even, even.
Correct? Even length palindrome over the symbol 0, 1. Right?
Yes, sir.
S gives 0, 1. That means starting symbol and ending symbol should be same. That is what we'll refer as a palindrome string, right? And its length is even. That means epsilon. Either it will generate two symbols at any instance, either those would be 0, 0 or 1, 1, or it will terminate with epsilon. So this is nothing but the case of 1B. Let's say W is even length, means we are considering epsilon as a even length string. Epsilon followed by it will have 0, 0 or 1, 1 or 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 1, 1 and so on. Correct? Because we are talking about even length only. We are not talking about odd length. We will never have 0, 1, 0 or 0, 0, 0 or any other thing. Okay. So I hope we can generate very well this thing from this. Yes,
Yes,
or
sir.
no?
Uh,
As gives, let's go for this 1, 1, 1, 1, 0, 0, 1, 1, 1, 1. That means what? This whole thing is W, which reads same forward and backward and having length equals to even. So on the left hand side and right hand side, we have symbol as a 1. So 1 S 1. Then again 1, 1 S 1, 1. We are applying just this rule. 1, 1, 1, right? S 1, 1, 1. So total 4 ones are there. Let's repeat it once again. 1, 1, 1, 1. S 1, 1, 1 and 1. With further 1, 1, 1, 1. Fifth symbol is 0. So it will have rule number 1. 1, 1, 1, 1. Last but not least, here we have nothing to take. So we'll go for S gives epsilon. And we know epsilon's length is 0. Ultimately, this means 1, 1, 1, 1, 0, 0, 1, 1, 1, 1. Isn't it?
yes, sir.
So this is your second example. Let's go for third example now. What does it says? It says L equals to A raised to power I, B raised to power J, C raised to power K, where I comma J comma K greater than or equal to 0. That means I, J, K could be 0 also. When we say 0, that means A, 0 number of A's, 0 number of B's and 0 number of C's. That could be a feasible string. Okay. Followed by, what is next? Next condition is
I equals
and
to
I equals to
J.
J or I equals to K. That means the number of A's is equals to B's or the number of A's is equals to C's. Right? We are talking about two different cases here. Case one is number of A is equals to number of B. Case 2 is number of A's is equals to number of C's, right? And by default, I, J, K is greater than or equal to 0. I, J, K is greater than or equal to 0. So let's talk about it. S gives, let's go for first case as a S gives S1 or S gives S2. That means we'll either have string generated belonging to case 1 or the string would be belonging to case 2. Understood? Yes or no?
Yes, sir.
Let's go for S1. S1 says what? Number of A's is equal to number of B's. Okay, so let's go for S1 is equals to AX, where A is equals to what we will do here, number of A is equals to number of B's. So number of C's, how many times we have K, that doesn't bother, should not bother us. So we'll generate C's with the help of this X or epsilon. It could be equals to 0 also. So X gives epsilon will give number of C's equals to 0. Or we can generate any number of C's with the help of X gives Cx, where with the help of A, we'll generate strings of A and B such that the number of A's is equals to number of B's. That means A, A, B. Okay, number of A is equal to number of B's. So as many number of times A is generating, those many number of times B will get generated. And it will have a sequence like that once A's are over, it will have same number of B's. And this could be equals to epsilon also. That is number of A's and number of B's is equals to 0 or more than 0. Likewise, we can go for S2. Now, what does S2 says? Number of A's is equals to number of C's. Okay. So let's go for A is equals to C's. So let's have A, S2, C. Now this will generate as many number of A's, those many number of C's, or we can terminate it with the middle symbol, that is B, which has no relation with how many times A's and C's are generated. Let's take B for that, where B is small b, capital B, or epsilon. Understood? So this is our
Yes, sir.
required CFG equivalent to 1C example. So our required context free grammar G is equals to how many variables do we have here? S, S1, S2, A, X, B. These all are nothing but the non-terminals or variables. Terminal symbols are A, B, and C, right? A, B, and C. These are terminal symbols. P is a set of production rules, which are nothing but this whole set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These all 11 productions are nothing but set of production rule, that is P. Last but not least, starting variable. Starting variable by default here is what? Capital S, from where we are having S1 for or S2, and from S1 this first case, from S2 this second case. So here we come to the closure of question number 1. That is, give context-free grammar that generate following languages. Any query on this?
Sir, can you explain me the why? मतलब S2 जब बनाया अपन ने A S2C ब्रैकेट B, तो सर जैसे इसमें एक ने X भी डिफाइन किया था S1 में, जिसमें C 0 भी हो सकता था या कितने भी नंबर ऑफ टाइम्स हो सकता था। सिमिलरली उसमें B भी तो कितने भी नंबर ऑफ टाइम्स हो सकता है। मतलब अपन ने इसमें A डिफाइन किया है, पर इसमें C नहीं डिफाइन किया ना कि C इक्वल्स टू A है।
यहाँ पे क्या ना, AS2C, what does it means? That is, S gives AS2. This fraction can be repeated for any number of times.
ओ,
In every case, it will generate one A
ओके
and
सर।
one C. So ultimately, by this, we are keeping track of that the number of A's getting generated is equals to number of C's.
ओ सॉरी सर, आई
And
थॉट सेपरेटली किया है अपन ने
this
दोनों।
B is in middle. So since it was in middle, we can very well take this with the help of this B. And here we are generating as many number of B's we want, or we can have direct epsilon also. So
ओके सर।
J equals to 0 or J greater than 0. That we are satisfying with the help of this production. Number of A is equals to number of C's, we are ensuring with the help of this. If I and K is equals to 0 in this case, then we'll directly go from S2 to B, where any number of B's can be generated. Okay?
ओके सर, we can go on to the next one.
We'll go for the last example for today. Now, what does it say? Please read for me.
Language which has A to the power n, B to the power m, and C to the power k, where n equals to m, or m is smaller or equals to k, where n is smaller or equals to 0, m is greater
N
than or
number
equals
of
to 0
A's, M number of B's, and K number of C's, right? That is
is.
for sure. Condition
Yes, sir.
is N is equals to M
Hmm.
or M less
Or
than equals to K. दोनों में से एक.
yes, sir.
और N, M, K तीनों भी greater than equal to 0. So basically we are talking about the same thing. This first part here. Only the way of writing is different. And here we are talking about two cases.
Yes, sir.
Case one is number of A's is equals to number of B's, and case 2 is MK, right? So number of B's less than equals to number of C's. So C's would be either equals to B or greater than B. Those many number of times it will repeat. Okay. So either first part or second part. S gives either S1, case 1, or S2, which will be for case 2. S1 is equals to. Now, number of A's is equals to number of B's. And how many times number of C's are there that we do not need, right? So case 1 talks about this thing. Generate this for same number of times and this for any number of times. So जैसा हमने last time किया था, AX, where A talks about A, B, or epsilon. X is equals to CX or epsilon. right? Case 1. Then case 2. What does it talks about? Case 2. Number of B is less than or equal to number of C's. Now, how many times number of A's are there? That doesn't bother here. So here we'll need, let's say, by, where B, with the help of B, will generate any number of A's, because it doesn't matter how many number of A we are keeping. It has no relation with the number of B's and number of C's. Okay, just hold on. So S gives here number of A's how many times, that doesn't matter. That will generate, we are generating with the help of B. And Y we will use to generate this N and C, B and C. So B, Y, C. It will ensure that number of B's getting generated equals to the number of C's, or number of C's would be greater than number of B's also. For that case, we will use another variable. Let's say B हो गया Z, where Z gives C, Z, or epsilon. Okay. So this is your required grammar for L equals to A raised to power N, B raised to power M, C raised to power K, where N is equals to M. Here we ensured that, or M less than equals to K. So M equals to K, that is B equals to C is ensured here, and C is coming at least equals to B or greater than B, that is ensured here. So any query about this?
No, sir.